Okay, so now we come to the third part of the video for today's asynchronous lecture. I consider this as the last part of the video for today's asynchronous lecture lah. Alright, so kalau tadi kita dah discuss about symmetric and skew symmetric matrices kan, macam mana rupa symmetric and skew symmetric matrices ni. Alright, so now we are going to find out what about their eigenvalues and its eigenvectors. Alright, okay, so it is stated here, eigenvalues of symmetric and skew symmetric matrices, dia punya eigenvalues are real. So far all the eigenvalues yang kita cari real. You tahu kan, we have real number, we have imaginary number sebenarnya. Imaginary number tu when you come across with the value somehow tiba-tiba kira keluar square root of -1. Nak cari lambda. So this is considered as imaginary or complex number. So for symmetric matrix, by right, its eigenvalues will be real. Okay, and then the eigenvalues for skew symmetric yang tadi tu, yang you try to buktikan B transpose is equals to -B tu, dia punya eigenvalues is either pure imaginary or zero. Lambda dia sama ada you dapat dalam bentuk I macam ni ataupun zero. Maknanya is zero tu considered real, tapi maknanya dia tak ada nombor yang nyata lah. Okay, you just can be sama ada zero ataupun imaginary. Tak adalah 1, 2, 3 whatever number macam tu. Alright. And then we focus on symmetric matrix, sebab symmetric matrix will give you real eigenvalues. You will have exactly n eigenvalues, okay, n eigenvalues, tapi not necessarily distinct. Yang ni yang tadi yang saya suruh you solve example 6b tu kan saya cakap lambda yang kita dapat tu -1 dengan apa satu lagi saya lupa dah, -1 dengan 2 kan. -1 ni it happened twice. Maknanya kita ada sebenarnya 3 eigenvalues but not distinct. Distinct ni maknanya dia tak sama. Dia not necessarily distinct ni maksudnya tak semestinya dia tak sama. It can be dia sama. Okay, -1 and -1 ni tak distinct lah, sebab dua-dua ni adalah sama. Kecuali kalau kita ada satu lagi nombor, katakanlah 4 ke 3 ke, okay, -1, 2, 3. All the values are distinct to each other. Tu maksud distinct. Saya rasa you all pun tahu kan. Alright. And there exists a set of n eigenvectors, one for each eigenvalue. Ni maksud saya cakap tadi. Yang sama juga dengan 6b yang kita discuss tadi lah. Walaupun -1 tu, kita ada -1, 2, -1. -1 ni dengan -1 ni benda yang sama. Tapi for each -1 ni, you should have its own eigenvector that are mutually orthogonal. Apa maksud orthogonal kat sini? Samalah dengan linearly independent. Kalau linearly independent, maknanya macam mana nak buktikan it's linearly independent? Just have to make sure its determinant does not equals to 0 kan. Alright, so alright, and we have example 8 here, but before we go to example 8, let's have a look dekat definition of this. Tadi kita dah discuss about the eigenvalue for symmetric matrix, skew symmetric matrix. Now eigenvalues of orthogonal matrix. It is stated here, the eigenvalues of an orthogonal matrix. Macam mana orthogonal matrix? Kalau matrix A tu, A transpose is equals to A inverse kan, yang saya suruh you buat as your classwork submission untuk buktikan yang matrix C tu dalam example apa? Example 7. Are real or complex conjugate in pairs and have absolute value 1. Okay. Untuk tidak menyusahkan hidup awak, saya rasa for this ni, saya just want to consider eigenvalues yang real saja. So kita tak payahlah fikir sangat for eigenvalues of orthogonal matrix dan juga eigenvalue of skew symmetric matrix. from example 7. So maknanya example 9 ni saya takkan discuss, tapi kalau you rajin, you can find out, you boleh buat lah. Okay, so tak wajib lah, yang ni sunat. Okay, sunat. Siapa yang rajin, you can try to work out example 9 on your own, but I'm not going to discuss because as I said just now, for your course, I will just want to consider the eigenvalue yang real saja. But to let you know, eigenvalue dia boleh jadi juga conjugates, complex numbers. Okay, complex number, and then complex conjugate ni pun saya rasa you all faham lah kan. Kalau you have a complex number 3 tambah 2i is complex conjugate, maknanya dia jadi 3 minus 2i. Alright, this sign change on the imaginary part. Alright, so to end today's asynchronous lecture, let's discuss example 8. Sebenarnya kalau you listen example 8 carefully, I'm going to show you the solution. Will help you to solve your classwork submission for today, for example 6b tu. Alright, so let's start with this example. We'll try to find the eigenvalues and a set of mutually orthogonal eigenvectors. So remember, to show that it is orthogonal, you just have to prove that all the 3 eigenvectors are linearly independent. Okay, so this is the matrix that kalau you nampak, this matrix is symmetry kan. Okay, and then you can try to prove lah A transpose is equals to A. Yang ni tak payah tulis pun, jeling dengan mata pun memang nampak it's symmetry, right? So we'll straight away try to find its lambda. Okay, so we have here 3 minus lambda 2 4. Kita buat laju lah sebab by right sekarang ni semua orang dah master dah benda ni. 4 2 3 minus lambda, right? Okay, so I want to highlight here because nak cari lambda kat sini is a bit tricky lah. Okay, so kat sini you nampak kita find its determinant. So what you will get here is kan 3 tolak lambda ni first, then you have negative lambda darab dengan 3 tolak lambda tolak dengan 8 pula 8 ke, negatif lambda darab dengan 3 tolak lambda tolak 4. Okay. And then you have minus 2, right? Ni 2 ni minus 2 darab dengan yang ni pula tutup yang ni 2 darab 3 minus lambda minus with 8, right? And then plus with 4 yang ni pula. Then you cross this one, you will get 4 minus 4 lambda, right? Okay, so here then you need to let it equals to 0. So apa yang kita boleh selesaikan kat sini? Maksudnya macam tak ada nampak apa-apa pun yang boleh you selesaikan kat sini ni. Okay, so there is nothing that you can factor it out because there is no common term between these 3 terms. Kan kita ada 1. Okay, we have 1 here, the first term here. Okay, 3 minus lambda yang ni. So yang ni saya just proceed untuk buka je lah. So you will have here negative 3 lambda plus with lambda square minus 4. Okay, and then here apa dia kat sini, minus 2 6 minus 2 lambda minus 8. Okay, and here you have 16 plus 16 lambda equals to 0. Okay, and then kat sini darab je lah. Okay. You try lah to solve on your own. I need to cut the time. Apa ni, kita afraid that we will not have enough time. So we will have here, kalau you open apa ni, kembangkan ni, you should get negative lambda cube plus 6 lambda square plus 15 lambda plus 8 equals to 0. Okay, and then nak cantikkan dia, kita jadikanlah, kita darab both side with negative. So we have lambda cube minus 6 lambda square minus 15 lambda minus 8 equals to 0. So it's a bit complicated for you to solve, to find out the roots for the lambda here. Okay, satu cara untuk you dapatkan salah satu root is you try to let lambda equals to, try your luck lah, lambda equals to the simplest number that you can have. Let's say lambda equals to 0. Kalau you put lambda equals to 0 inside here, will it be equals to 0 on your left hand side? Because on your right hand side memang you nampak is equals to 0 kat sini kan. Kalau you gantikan kosong dekat lambda ni, no, you can't get, because you will get negative 8 kan on your left hand side. So it's not equals to 0 on your right hand side. So salah. So let's try lambda equals to 1. If you let lambda equals to 1, gantikan, so you dapat if lambda equals to 1, you will get 1 tolak 6 tolak 15 tolak 8. Sama tak dengan kosong? Negatif 5. Okay, lambda equals to 1 pun macam tak jadi. 1 tolak 6 is negatif 5. Negatif 5 tolak 15, negatif 20 tolak 8. Tak jadi. Cuba try negatif 1. Okay, minus with 1. So negative 1 power of 3 is negative 1. Negative 1 square darab dengan ni 6 tolak 6 sama. Ni minus negative 1. Negative 1 minus times with negative 15 will be positive. So what you will get this time? Nampak macam jadi ni. Negative 1 minus negative 6 is minus 7 plus 15 jadi 8. 8 tolak 8. Yes, it's equals to 0. So maknanya kat sini lambda cube minus 6 lambda square minus 15 lambda minus 8 equals to 0. One of the root is lambda equals to negative 1. So maknanya lambda tambah 1 is equals to 0. Then we have lambda plus 1 equals to what? Tu apa? Kita tak tahu apa benda ni. Is equals to lambda cube minus 6 lambda square minus 15 lambda minus 8. So to find what is this value, maknanya you kena bahagilah. Okay, kita kena, sebab kita nak kena selesaikan this factor ni, right? Okay, so katakanlah ni adalah P lah. This P ni maknanya P is equals to lambda cube minus 6 lambda square 15 lambda minus 8 over lambda plus 1. Kena cari. Okay, what is the factor for P? Okay, so basically ni yang paling susah lah ni sebenarnya. Saya nak tunjuk ke awak ni cara dia. Jangan stress pula. Okay, to find the what is P kat sini, maknanya you need to use long division. Maknanya kalau 10 bagi 5, masa you dah scroll rendah dulu, macam mana you cari? Macam ni kan, 10 bagi 5, 5 darab berapa nak dapat 10? Macam tu lah. So the same concept as here. Okay, lambda plus 1, lambda darab dengan berapa nak dapat x cube? Okay, lambda darab berapa untuk dapat x cube? Lambda darab dengan berapa untuk dapat lambda kuasa 3? Of course, lambda kuasa 2, right? So this one, you will have lambda kuasa 2 darab dengan lambda. You get lambda kuasa 3, lambda square darab 1, we get plus lambda square. Lepas tu tolak lah. Kat sini, you gonna have minus 7 lambda square. Okay, and again here, 7 lambda square nak dapat lambda darab dengan berapa nak dapat minus 7 lambda square. Okay, ni 7 lambda square. So untuk dapat 7 lambda square, lambda ni of course you kena darab dengan minus 7 lambda, right? So minus 7 lambda darab dengan lambda is minus 7 lambda square, and then minus 7 lambda tambah 1 darab dengan 1, so you get minus 7 lambda. Okay, so yang ni tolak-tolak, you akan dapat kosong kat sini, and then minus 15 lambda minus with 7. Okay, jadi tambah negatif 15 lambda tambah 7 lambda, you gonna get negatif 8 lambda. Okay, negatif 8 lambda. So here you will get lambda darab dengan berapa nak dapat negatif 8 lambda? So, darab dengan negatif 8. Negatif 8 darab dengan lambda, you're going to have negatif 8 lambda. And then, negatif 8 darab 1, you get minus 8. Okay, so ni nampak tak? Negatif 8 tolak-tolak jadi kosong. 8 ni pun tolak-tolak jadi kosong. So, maknanya yang ni, hasil darab dia adalah lambda square minus 7 lambda minus 8. Okay. And then, daripada sini, maknanya, okay, clear? So, maknanya yang ni, okay, the roots are lambda tambah 1 darab dengan lambda square minus 7 lambda minus 8 equals to 0. Lambda square minus 7 lambda minus 8 ni dapat tak factor? Yes, you gonna have minus lambda minus 8 lambda plus 1 equals to 0. Nampak tak? Kat sini maknanya we have two repetitive roots of negative 1. Basically, you have lambda equals to negative 1 and lambda equals to 8, right? But remember, lambda equals to negative 1 occurs twice. So, you need to find two eigenvectors for lambda equals to negative 1. Okay, so bila kita gantikan dalam matrix with lambda equals to negative 1, maknanya kita akan dapat 3 tolak 1 for the first value. 2, 4 tu remain the same lah. And then 2, and then kosong tolak dengan negative lambda. So, negative lambda kat sini negative 1. Okay, and then we have 2 here. And then 4, 2, 3 minus with minus 1. Okay, and the matrix is x1, x2, x3 is the eigenvector. And this one is 0, 0, 0, right? Okay, so apa yang you dapat kat sini sebenarnya? 4, 2, 4. 2, negatif 1, 2. 4, 2, 4 juga. Okay, and then you have x1, x2, x3. 0, 0, 0. So, kalau you darab ni, you akan dapat apa? 4x1 plus 2x2 plus 4x3 equals to 0. And then here, you're going to have 2x1 minus x2 plus 2x3 equals to 0. And then, the third one, sama je kan? So, I don't think there is a need for you to check for the third one sebab sama, you akan dapat sama. 4x1 plus 2x2 minus 2x3 plus 2x3. Okay, kalau yang ni maknanya you can factor kan. Yang first ni you can factor, dia akan jadi by factor of 2, you akan dapat 2x1 minus x2 plus 2x3 equals to 0. Okay, sorry, plus, okay, plus 2. Okay, yang ni yang satu tadi sama je. Yang ni yang kedua. So, maknanya sekarang yang kedua ni, what you have is 2x1 tambah 2x3 is equals to x2. Whereas another one, 2x1 plus 2x3 is equals to negative x2. So, you need to have the values that satisfy both conditions here. Okay, you need to have the values that satisfy both conditions here. So, let's say kita nak let x equals to apa? I think yang paling selamat adalah dengan let apa? Oh, sorry class. Tengok ni. I notice I made a mistake here. Okay, yang ni sepatutnya positif. Ni sepatutnya positif ni. Sorry. Okay, this one supposed to be positive. Yang ni pun sepatutnya positif. So, sebenarnya tak ada isu ni. There's no such thing yang ni kedua ni. Semuanya jawapan akan jadi sama. Sorry. Patutlah saya macam confused tadi. Yang ni salah saya erase. So, basically, kita punya ni adalah sama je. 1, 2, 3 ni semua sama. So, because this one is a positif yang ni. So maknanya kita punya relation adalah 2x1 plus 2x3 is equals to negative x2. Okay, negative x2. Alright, so there are few options that you can choose. Okay, untuk senang, you can choose apa? We let x2, saya nak let x2 equals to 0. If I let x2 equals to 0, maknanya kita akan, salah tak? Boleh tak x2 equals to 0? Yes, no problem. As long as bukan vector yang ni, x1, x2 semua kosong. Tak boleh lah. It should have, if only one element is 0, it's fine. So, what we have is 2x1 plus 2x3 equals to 0. So, in this case, we have 2x1 equals to negative 2 x3, then over here we have x1 equals to negative x3. So kalau saya let x2 equals to 0, then meaning that my eigenvector, we have 0 in front, 0 in the middle for x2. x1 ni any number, x3 should be the same number but opposite sign. So nak senang, kita let x1 equals to 1, x3 equals to negative 1. Boleh je. Nak proof boleh ke tak, then you can try lah. How to check whether this eigenvector is correct or not? Saya tahu memang dah betul lah ni. So saya tak nak buat proof lah. You can prove ax equals to lambda x. Okay, I leave it to you to prove. Okay, remember lambda equals to negative 1 ni 2 kali tadi kan. So we need to find twice 2 eigenvector. So the first eigenvector, I choose this one. The second eigenvector, can we let x2 equals to 0 juga? If you let x2 equals to 0 juga, and then you choose any other number, katakanlah you choose, tak apalah kalau yang ni maknanya kita pilih kosong, kali ni kita buat x1 pula negatif, then x3 become positive. Boleh tak? Okay, can we accept both of these eigenvectors? Jawapan dia tak boleh. Sebabnya, this is considered linearly independent. Katakanlah saya kata ni adalah apa nak cakap x1, ni x2 kan. Maknanya kat sini x1 ni adalah negative of x2. So dia adalah linearly independent. Kita kena cari value yang mana dia tak berkait langsung. Alright, so this is not correct. So sekarang ni maknanya try to let x2 with something else. Let x2 equals to apa agak-agak. Let x2 maknanya tak jadi sama dengan kosong lah. Let x2 equals to 2 for example. Okay. Let x2 equals to 2, then what you will get? If you let x2 equals to 2, then okay, so if we let x2 equals to 2, using this equation, kita akan dapat 2x1 plus 2x3 is equals to negative 2. Okay, negative 2. Then, maksudnya kat sini, faktor belaka x2 ni, you get x1 plus x3 equals to negative 2. Okay, there's no choice. You need to let kita dah let x2 equals to 2. Okay, so to get x1 and x3, you have to let some other value lah. Okay, maknanya kena let lagi. Let x1 equals to what value? Okay, tak apa, jangan risau. Okay, you can let x1 equals to apa? Katakanlah this time kita let x1 ni sama dengan whatever value that you want to let lah. Okay, let's say here I let x1 equals to 0. Then if I let x1 equals to 0, my x3 will be equals to negative 2. Boleh tak macam tu? Okay, my x3 is equals to negative 2. My x1 equals to 0, my x3 equals to negative 2, my x2 is equals to 2. So let's see. Okay, this one, then what I will get is 0, x2 is 2, x3 is negative 2. Will it satisfy the condition here? Okay, kita akan dapat x1 kosong, 2 darab dengan x3 is, sorry silap lagi, yang ni sepatutnya 1 kan, bila saya faktorkan semua ni out, so you get x1 plus x3 equals to negative 1 lah, bukan negative 2, patut pening tadi pun. Okay, negative 1, sebab ni kita faktorkan, kita bahagi semua ni dengan negative 2, bagi semua dengan 2, so you get x1 plus x3 equals to negative 1. So if we let x1 equals to 0, then x3 is equals to negative 1. Silap ni. Negative 1. x3 equals to negative 1. So if we check, is it independent ke tak? Between the first eigenvector with the second eigenvector, kalau you tengok, no, it's independent. Yes, it's independent. Dia tak ada kata hasil darab of apa-apa. It's multiple of each other. No, it's not. Alright. So, next, let's try to find kalau we have already 2 eigenvectors. So, now you need to find for lambda equals to, satu lagi apa dia punya factor is lambda equals to 8, right? So, untuk lambda equals to 8, maknanya kita kat sini kita ada equals to 8, then we have 3 minus with 8, and then here minus 8, and here is 3 minus 8, so maknanya kat sini, alah lupa sapu yang ni. Okay, maknanya kat sini adalah negative 5, this one is negative 8, and this one is negative 5. So what you will have here is negative 5x1 plus 2x2 plus 4x3 equals to 0, 2x1 minus 8x2 plus 2x3 equals to 0, 4x1 plus 2x2 minus 5x3 equals to 0. Okay, kita try simplify yang second equation ni. Nampak senang sikit. Yang lain tak dapat kan? Tak boleh nak factor. So, kita bahagi dengan 2. So, we get x1 minus 4x2 minus x3 equals to 0. Cubalah agak-agak a value that will satisfy equation 2 ni. Nampak macam senang sikit ni. What shall we let x1, x2 and x3? Kalau kita let x1 equals to 1. Okay. x1 equals to 1. Then, boleh tak? x1 equals to 1. Macam susah sikit kan. Okay, let x1 equals to 2. Kalau kita let x1 equals to 2, then any value that satisfy the condition, you can assign any value. Okay, x2 saya let x equals to 1, and x3 saya let equals to 2 juga. Nampak tak? So kalau lah ni x1 maknanya 2, tak boleh, 2 tolak dengan 4 darab dengan x2 is 1, and minus x3 is also 2. So dapat tak? Ya, kita dapat 2 tolak 4 tolak 2 kosong. So it satisfy the second condition. Looks good. Let's try kalau kita masukkan dalam first condition. You kan tak boleh tengok untuk satisfy the first only one equation ni. You kena make sure it satisfy all the 3 equations. Okay. So kalau kita masukkan yang ni, kita akan dapat negative 5 darab dengan x1 is 2 tambah 2 x1 is 1 and 4 x3 is 2. Dapat tak? Negatif 10 tambah 2 tambah 8. Dapat. So, is equals to 0 kan? Negatif 10 tambah 2 is negatif 8. Tambah 8, kosong. Okay, looks good. It satisfy the first condition. Then, let's try the third equation. It satisfy or not the third equation. So, you get 4 darab dengan 2 tambah 2 darab dengan 1 tolak 5 darab dengan 2. So, 4 darab 2, 8 tambah 2, 10 tolak 10. Yes, it satisfied. So, yeah, why not? Then, meaning that for lambda equals to 8, your eigenvector will be 2, 1, 2. You can give yourself a try also with other numbers. Any number will do, but make sure if you assign all the numbers, you put inside the equation, you satisfy the equations. Okay? And to be safe, ni saya tak tunjuk lah sebab saya tak cukup masa. AX equals to lambda IX. Proof. Kalau dia dapat jawapan yang sama, then if you able to prove that it's equals to left hand side is equals to right hand side like what we did before, then your answer is correct. Okay? So, maknanya sekarang ni kita dah ada all the 3 eigenvectors. The 2 eigenvectors belongs for lambda equals to -1. And the last eigenvector that we found just now is for lambda equals to 8. So, maknanya sekarang ni we put in all the 3 eigenvectors together. First row for lambda equals to -1, I get 1, 0, -1. The second column is for lambda equals to -1 also, which is another linearly independent eigenvector, 0, 2, -1. Okay, nampak tak? Dia tak ada kaitan. And then the third vector is 2, 1, 2. Also by right, kalau tengok dia tak ada kaitan juga dengan another 2 eigenvectors here. So, kalau nampak ni pun saya dah yakin dah it's an independent eigenvectors, all the 3. But to prove that it's orthogonal, you have to make sure it's linearly independent. So I leave it to you to show that the determinant of X is not equals to 0. Okay, cari sendirilah ni. I leave it to you. Masa pun dah saya tak nak panjang sangat your YouTube. So then you can find the determinant you should get. It is not equals to 0, so that is all matrix A is an orthogonal, okay, matrix, okay, because, okay, X is linearly independent. Dependent pun dah aja kali dependent. Okay, is independent because matrix X is linearly independent because you have proven that its determinant does not equals to 0. Okay, jangan tunjuk macam ni je. You have to show lah what is the value of the determinant. Cari dah. Alright class, so with this we have completed today's asynchronous lecture, and I think maybe we'll able to complete chapter 1 in our next class during Google Meet, inshallah. Alright, so that's all for today everyone. Thank you, and if you, do not forget to submit your classwork submission by 11:59 PM tonight. Okay, that's all for today. Assalamualaikum warahmatullahi taala wabarakatuh, and bye bye.